So look at this new problem related to slope stability on engineering geology. And so first of all, look at the question. The question is orientation of slope face in an area is 60 degree towards 220 degree. A weak plane is exposed on the slope with orientation 50 degree towards 210 degree. Frictional angle of the plane is 30 degree. Determine whether planar failure is possible or not. Okay, so this is the very simple question. Okay, so look, how do we solve using this stereographic projection? Look, uh, first of all we need to draw all the we need to draw this slope face. Okay, we need to draw this slope face. So look, the slope orientation of the slope face is 60 degree towards 220 degree. So 220 degree, this is south, so 180, then 190, 200, right, 210, 220. So this is 220 degree. Okay, 220 degree. Okay, clear? And now look, if you so first of all we will draw the slope face. Okay, so this will be the strike of the slope face, right? This will be the strike of the slope face, and this will be another strike of the slope face, right? Okay, and always remember we will take a zone. Okay, rather choosing a red circle, we will take a zone, so that zone will be within the 20 degree plus and 20 degree minus with respect to this strike. Okay, so if you just go 20 degree towards this side, it will be somehow here, right? And similarly, if you go 20 degree towards this, in this directions, it will be somehow here 20 degree. This is also 20 degree. Okay, clear? And now we will simply so these are the 20 degree angle. Okay, and then mark the other 20 degree distance, 10, 20. So this one, and also this one, this is also 20 degree. And now we have to draw the circle using the frictional angle. The frictional angle has been mentioned as how much? It has been mentioned as 30 degree in the question. So 30 degree means on a vertical plane, if you just measure 30 degree, so this will be 10, 20 and then 30, right? Okay, so look, 10, 20, 30. Okay, and we can do other thing also. We can draw the initial circle, initial great circle. That means the orientation of the slope face 60 degree towards 220. Okay, this one, clear? Now let's draw the circle. Okay, Okay, I have just drawn the part of this circle, or okay, let's draw the full. Okay, using the frictional angle, right? And right now what you will do, we will simply we will also draw an arc using these two strike. Okay, and that will also have, that should also have the same amount of inclination as the face, as the slope face. So slope face was it was 60 degree, right? 30, 40, 50, 60. 60. Again we will draw another strike line having same dip. Okay, now we will mark the unstable zone. Okay, now we will mark the unstable zones. Okay, so look, which one will be the unstable zone? I am marking the, or I am giving the boundary of the unstable zone using this red color. Okay, so the area inside these red lines all are unstable part. Okay, so that means this part are very much unstable. Okay, these all are very much unstable part. So look, all these areas are unstable part. Okay, so right now in the given question, the mentioned orientation of the weak plane is 50 degree towards 210. Okay, so we will now just draw this weak plane. We will draw this weak plane. Okay, let's draw it 60 degree towards 210. So 210 degree is actually towards 220, so this is definitely 210. And now we will just measure the angle of 50 degree towards 210. Okay, so we will measure 50 degree, 10, 20, 30, 40, 50. So now this one is weak plane. So now the question is whether failure will occur or not. Failure will definitely occur. Why? Because look, the slope face is towards 220, and this is only the 10 degree distance from the slope phase direction, right? So, and also the great circle also lies in the unstable zone, right? So planar failure will definitely occur.